Okay, hi. We're going to try an example here. I'd like you guys to be able to pause this and make sure you know how to solve it. So when you're working this problem out, okay, I'd like you to use the controls on the on your phones or on the computer to solve for this. Okay, so here's the situation. I'll read it to you, and then I'll list the variables, and I'll ask you to calculate the acceleration. Okay, here we go. So here's our situation. The other day, my car broke down because I ran out of gas. So I had to push the car. Okay, the car's mass, we'll give you that, okay, was 1,100 kilograms. Okay, that's the car's mass. So I had to push the car, and a force applied to the car, about 350 newtons of force. That's what I applied constantly. So I've got the mass of the car, I've got my applied force, but obviously there's some friction between the wheels and the road, so I've got to include that. So I'll give you that too. The force of friction, okay, was 100 newtons pushing back on me when I pushed on the car. Okay, so my question to you is calculate the acceleration of this car. Okay, so at this point, what you want to do is you want to solve for acceleration by using the information that I've given you. Okay, at this point, you can pause the video to see if you can hash out the problem. If not, I'm going to continue and solve this with you. Okay, so now I would originally start by doing step one and drawing a picture of the car, okay, on the road. Add in some forces. Okay, we know that these two equal out, the normal force and the weight equal out, so we're not considering that right now. There's also the applied force, F sub A, and there's also the force of friction, F sub F there. Now, there's the first step, just to see what's happening. Now, I would go ahead and get a free body diagram going on that. So here's my car. Okay, the normal force and the weight cancel. Okay, and I've got an applied and I've got a frictional force. Okay. Okay, we just lost our lights, but I think we'll still be able to work with this. Okay. Okay, so as you're solving, okay, again, pause it. If you go on and solve this on your own, I want you to pause it and see if you can get the answer. Okay, so force applied and force of friction. So I know that this one here going to the right is 350 newtons. One going to the left is 100 newtons. Okay, so the sum of forces here, adding up all these forces, these two cancel, they're not in the picture anymore. I'm going to add 350 plus negative 100. So the sum of forces ends up being 250 newtons to the right. Okay, so I've got that. So I can actually add this in over here. Sum of forces is positive 250 newtons. Now that means that I can actually take and get rid of this and get rid of this, because in essence I've solved for those already. They're gone. Okay. What I'd like you to do is again, pause it if you'd like to solve for this, and see if you can get the answer for the acceleration. All right, but I'll continue on. Okay, I know that the acceleration is the net force over the mass. So all I'm going to do is a little plug and chug here. Net force, I ended up with positive 250 newtons. Mass of the car, Well, if I look back up here, it's 1,100 kilograms. So I would just plug 1,100 kilograms into there. And then I would grab the calculator, which is fine. And I would go with 250 divided by 1,100. 250 divided by 1,100. Okay, and let's try again. 250 divided by 1,100. Okay, so I got an acceleration of 0.23 meters per second squared. Again, if you want to get that in scientific notation, it's 2.3 times 10 to the negative 1 meters per second squared. So it is accelerating indeed to the right. It's not going to be a quick one, but it is accelerating. Okay, so that's how you get that problem done. If you got an answer of 0.23, you are correct. Okay, that's your example. Okay, I'm gonna give you some more examples of that in class. All right, guys, thank you very much, and have a great day.